Good afternoon, YouTube. How's everybody doing? I'm Greg from GregsTutoringNYC at gmail.com. I'm a tutor. I reside in New York City, although a lot of what I talk about applies to really testing across the whole country, although I do talk about tests specific to New York City, like some of our specialized high schools and high schools in New Jersey, in Boston, Connecticut, and the Northeast area of the country, but there's also generic stuff like the ISEE and the SSAT. So this is part two to a YouTube I did yesterday pertaining to greatest common factor and least common multiple. So first of all, if anybody's listening, I want to make sure I'm live and my mic is okay. I turned it on. I had it off before, so I believe it's coming through. So what we're going to do is just jump into some of those. If you didn't see part one to this, please replay it so that you can get up to speed, because I'm just going to jump into this. And there's going to be a part three to this because I believe I have to step out for a few minutes, and I want to kind of get this LCM, GCF stuff over with today. Actually, I'm zooming around. I have a bunch of notes, and I want to make sure that I'm just calmed down for a few seconds, and I can catch up on what I even have written here. So give me 2 seconds. Just to find out what page we were up to yesterday, because I have about 10 pages worth of stuff about this. So that's no good, because I'm zooming, and like I said, I need to stop this at some point so that we can resume at some point. Give me 1 second. That's page. All right, I think we're up to here, because I did not get a chance to refresh this. Yeah, so we talked about a lot of general cases that have come up. There's actually a couple of pathological cases. Some kind of start pushing this, but I just want to make sure I'm semi-thorough, because these can sometimes come up in a test. And if you're just so used to following the robotics of this, which you shouldn't do, and I'm hopefully going to get that either in part two or part three, we're going to talk about that. As much procedures I showed you guys yesterday, going through a procedure to resolve this stuff, when you get to the word problems and so on, don't depend so much on it. Okay? You have to go with your flow. You have to become one with the problem. Okay? And really synchronize with the problem. That sounds a little hokey pokey and Yoda-ish, but there's some point where you need to get the mastery of the math down that much. Especially some tests, if you're just taking the state test for your school, you probably don't have to worry about some of this stuff. If you're in elementary school, some of the stuff I'm about to talk about, you usually don't need to care about it. If you're in middle school, you usually don't need to care about it. But some of the stuff I'm about to talk about, if you're taking an entry into high school test, and really anything after that, you may or may not have to know some of this stuff. So let me just go through an example, the first one. So if we have 54, okay, and 35, and let's say we want to either get the greatest common factor or the least common multiple of this. So if you follow the rules we did yesterday, we do a prime factorization, okay, and what I do, that's 27, that's 3 and 9, and this becomes 3 and 3. Let me make sure that's what's showing on the screen. There seems to be a huge delay on my connection here today, although if it's working, that's good. And 35 becomes 5 and 7. So the factors for here, the prime factors, become 5 times 7 for that, and this becomes 2 times 3 times 3 times 3. All right? And we talked about certain things. For instance, when you get the GCF, you're looking for the greatest common factor. The common factors. Well, it turns out there is no common factors. There's no common factors. We're supposed to match them up one by one and pick them out. There's nothing to match up here. There's 1, 2, there's no 2 there. There's 3s here, there's no 3s there. There's 5s here, there's no 5 over here. So this means the GCF is 1. Okay? So watch out for the scenario. They may throw this in, especially if this somehow turns out to be a divisor or something. It's not 0. First of all, you can't have a divisor of 0. It's undefined behavior. And if you get a word problem where you're writing stuff out, sometimes it's multiple choice, sometimes it's a grid in, sometimes you actually have to show out all the work. You want to make sure that you're remembering that if there's no common factor, the GCF is 1. Okay? And the LCM, if there's no common factor, is the whole factor list spelled out. So you're going to get 2 times 3 times 3 times 3 from the 54, right, times the 5 times 7 of this. So basically what we're doing is multiplying these two numbers out, because that's all the factors of both of them. And in this case, I did it before, and we're going to get 1890. Okay? So it turns out the multiple, since there's no factors that are common, the multiple is just multiplying the two of them together, is really what this truism comes out to be. So that's kind of the first gotcha. That there's no common factors, the GCF is 1, and the LCM is all the factors, which since these add up to the number, right? 3 times 3 is 9, 27, 54, and this is 35. We're essentially just multiplying the two numbers. So that's one of the gotchas for there. Okay? So there's a second gotcha, which is if you do the LCM of something involving a 0, all right? And this is the same as, because we normally don't care, these are not positional. We don't normally care which order we put them into. All right? So this is undefined. There's a good explanation for it. I'm not going to give it right now. We're just going to be brief. I could get into a whole bunch of stuff. It's just confusing mathematical stuff. And really you need to know for some of these tests, or just know when you're doing LCM, the least common multiple, that if one of them is 0, there's no common multiple then. It's just undefined behavior. All right? If you do the GCF with something involving a 0, okay, that's the X. All right? So these are things you need to be aware of, because one's undefined and one is defined. So just think there's no multiples of zeros, even though that's technically incorrect. There is multiple of zeros. It's every number is a multiple of 0. Okay? And the factor is the one number here. And again, we can go through details of how that's the case or not. If anybody wants these explained, please email me at GregsTutoringNYC@gmail.com, and I could pop you out an explanation of that. So that's the one scenario where there's no common factors. The other scenario is one of the two numbers is 0. Okay? That's 6. What else I have in these notes? Oh, okay, yeah. So the next scenario involves when you have the LCM of more than two numbers. Let's say you had X, Y, Z, and the GCF of more than two numbers. I'm just going to use 3, but it could be any extent of it. All right? So of the LCM, it's going to work the same way as it worked before. We're just going to add on a third number. So for instance, if we had 3, 6, and 9, this is 3 times 3, 3 times 2, and this one's 3 times 3, right? This is 3 times 2. So the greatest one says the common ones, the LCM says to get the total number of each unique one. So there's 1, 2, and this one has 2 3s. And we get 18 for the LCM. Okay, the greatest common factor, there's 1 3 here in each one of them, and that's it. There's no other 3. So the LCF in this case was, LCM in this case was 18, and the GCF was 3. I'm going through some of this faster than I did with some of the other stuff. First of all, I have, like I said, I'm probably going to split this into part 3. The other is some of the details are not important to this. Just be aware that it's more than n. It's okay. Okay. Now we have LCM involving negative numbers. So we may have -1 and 99, for instance. Or we may have 1 and -99. Or we may have -99 and -99. Okay, normally you're not giving the same number, so -88 or something like that, right? So you need to look at these as if they're the normal way. In other words, make believe they're positive. So just make believe there's negative inputs to LCM, that it's positive. Okay? The GCF with the same kind of issue. If I have 199, 1 -99, or one where both of them are negative. Okay? We're also going to work it the same way as if they're both positive. Let me just double check this. I don't do this myself often, so let me see. LCM with negative inputs. Right, we assume they're positive. GCF with negative inputs. Also assumes they're positive, yes. All right. So that's some of the pathological cases. Now the question is, it comes up, kind of what do I do in actual usage of this? Let's say I had a word problem. All right. Let's see, what time is it? 4:30. Yeah, let me do the word problems, because I was thinking of ending this now, maybe putting that in the part 3. Let me bring up a file so I can pop up some info here. Give me 1 second. Anybody has any questions, don't hesitate to ask them. I see there's a bunch of viewers on this right now. Give me 1 second. Let's see, where are we at the end of the document? All right, let me try to pop this up on the on your screens. Give me 1 more second. Wait a second, it's not showing. All right, here we go. So we'll try to start scrolling through this. Wait a second, my computer's semi-freaking out here. One more second, everybody. I'm rushing too much today. So the basic question is, when we're presented with a word problem, kind of what do we do? All right. So this kind of part of things is going to address that. So which do we choose? All right. So I'm going to give you some kind of things to follow and consider, but like it says here, nothing is a substitute for actually reading the problem. And when we do the part 3, I'm going to do a scenario where what I'm about to show you actually doesn't work. So the best way to solve problems is with your head. I'm just trying to give you some little more details to try to bite off problems. So when you're doing the least common multiple, there's normally something reoccurring and repeating. Something that's cyclical, like every X days, or things that happen simultaneously. So you're going to see keywords like at the same time, both. And since it's the least common multiple, you're going to see words like least and smallest. Okay? So here's an example. Greg tutors math every 5 days and ELA every 3 days. And how many days will he tutor both subjects? So I'm going to do another version of this with emphasis, where it's going to emphasize every 5 days, every 3 days, and how many days will tutor both subjects. So this more or less begs that this is an LCM problem, least common multiple problem. So what you want to think to yourself is something reoccurring? If it is, I probably need a multiple. Then there's no guarantee to this, but you probably need a multiple. So this is kind of what you want to think about when you're looking at some of these word problems. This is more of a simpler word problem, especially when it's straightforward like this. It's kind of easy peasy to match up this repetition, this simultaneousness, and things like that together. And the way to solve it is we're going to break down the every 5. We get 5, 10, 15, 25. And we can do this with the prime factorization as well. And every 3 is the 3, 6, 9. And we see that the smallest common multiple is going to be 15. Okay? So in 15 days, Greg will tutor both ELA and math again. Again, because this looks about something reoccurring. All right? And again, I could have used the prime factorization. So for greatest common factor, just like the issues up here, this block of stuff here, there's a similar kind of group of general ideas to consider with that. Actually, I'm not sure that's showing up in your guys' screen highlighted. So sorry about that. I'm not sure because this is out of sync by the minute as well. Let me just see if it shows up. No, it is. Okay. So for GCF, there's an equally bunch of things here where things are more being shared equally into groups. And because GCF and LCM deal with integers without talking about remainders, we're talking about evenly factored groups, equally shared groups, equally split groups, broken into equal parts. Okay? And since it's the greatest common factor, we're normally looking at the largest and the biggest and the highest and things like that to indicate that we're looking for a factor. All right? So let's give an example of that. So Greg wants to tutor 9 kids in math and 6 kids in ELA in overlapping multi-topic tutoring sessions. He wants optimal time spread. Okay? So how many math and ELA sessions will each student partake in? So I'm trying to optimize that I want to tutor 9 kids and 6 kids together somehow in one or more sessions. And what's the kind of optimal setting for this? I might not like the answer, and I might change my criteria, but for now, I have a certain amount of seats in the class, I have a certain amount of free days, and this is kind of where I'm thinking about. So how can I break this up even? Because I don't want 4 math kids and no ELA kids. I want it to be shared, and I'm gonna maybe they're gonna work in groups and I'll help them, or maybe I'll walk around the room and spend my time more with the math kids than the ELA kids, or vice versa. So I'm just trying to come up with a configuration that makes sense here. So how many sessions will each kid partake in? And how many total kids can I do simultaneously? So these are 2 questions here. All right, so we're going to do the with emphasis version again. So we're talking about Greg wants to tutor 9 kids and 6 kids in overlapping. So this concurrent, simultaneous kind of thing that we talked about up here, where it's being shared equally. Something's happening equally and going on at the same time. All right? Also, how many will each? When we're talking about each, we're talking about probably doing divising. And if it's each, and we're talking about integers, we're talking about sharing equally with no remainder. And then how many kids will Greg tutor simultaneously at the same time? But again, it's broken down altogether. So, so we're going to think, well, I need to take something and divide it. I probably need a factor, right? All right, let's just make sure this is going. Every 15 days. Yeah, Leah, you got it. Sorry, I didn't say that. My screen has so many tabs open that I'm dizzy. I'm trying to get this done so I can get to something and flip back into this on another thing. All right, so what about this one? So we have 9 and 6. So whether it's LCM or GCF, we're still going to look at the prime factors. So for 9, we get 1, 3, and 9. And for 6, we get 1, 2, 3, and 6. So 1 and 3 are common out of the two groups, but 9 and 6, 3 is the most common one. All right, so my GCF, my greatest common factor, the fact that it's common to these two sets, and the largest one turns out to be 3. So I will end up having 3 classes. Okay? Since I want to tutor 9 kids and 6 kids, right? We're just going to end up dividing that at the end. By the way, the thing where I had the prime factorization, that's just explaining what you guys already know. It's just the second way to do it. The first way is not using prime factorization. It's just listing the factors out and looking for the common ones. This works the same way. You know both techniques now. So now that we know that the greatest common factor is 3, we're just going to divide it into each of the number of kids. So 9 kids for the math divided by 3, and 6 kids for the ELA divided by that. So that's what I'm going to do. I'm going to tutor 3 math kids and, sorry, did I write that wrong? Let me see here. Should be ELA. So I'm going to do 3 math kids and 2 ELA kids all in the same room at the same time. That's up to me. I'm a genius. Let me figure out how to do it. All right, so I might have the ELA kids working on problems while I'm instructing the math kids how to do something. Like I said, I could walk around the room. I could just wait for the math questions. There's 1,000 scenarios here. So I'm going to do 3 classes with 3 math students and 2 ELA students each. Okay, there's other ways to solve this, but we're using this using LCM and GCF. Okay. Let me see, what else do I have here? Give me 1 second, I'm sorry. Yeah, you know what? I'm going to end this and come back. Maybe the next one, I think I put at 5:15. I might come back earlier or not. I guess I'll just start it up when I'm free. And okay, so hopefully everybody, this is part 2. You have to look at the part 1 first to probably understand some of what I'm saying here. If not, anyway, we went through the pathological cases, and I'll be back in half an hour or so, guys. All right, peace out.